channel information. Today I will be starting a new chapter in organic chemistry, the general organic chemistry. It was the first, which is a basic chapter, come under basic tools for learning organic chemistry in masters and CSI net. So in general organic chemistry, we discuss basically about the effects which can be further divided into two parts, just like primary effect and the secondary effect. So in primary effect, we deal some of the effects such as electronegativity and size of elements. In secondary effect, mostly these are the important facts. Here we discuss about inductive effect, hyperconjugation, resonance, and fourth, the mesomeric effect. So let's deal with the first type of effects, the primary effects. So if we discuss in the periodic table, we know that if we go across the period, the size of the elements decreases and electronegativity increases, and if we go down the group, then electronegativity increases and size increases. So there are some relations which is important for learning the general organic chemistry, which we need to know. Just like acidity is directly proportional to the hydrogen ion concentration and inversely proportional to the pH, and directly proportional to the Ka value and inversely proportional to the pKa value. And about the percentage character, if we go from 3 degree to 1 degree, the 3 degree hybridization, the bond angle increases and percentage character also increases. And the next point which is important is that more electronegative and negative charge stable होता है. And this statement, more electronegative and negative charge stable होता है, is only applicable in a period. Do not apply this in a row. Only applicable in periodic table. So let's take an example. Let's take an example of HF, HCl, HBr and HI. We need to know who's the strong acid to know the acidity. We first need to see the stable cation. So if H plus and F minus, H plus and Cl minus, H plus and Br minus, H plus and I minus. So to know who is the strong acid, we see the stability of an ion, the fluorine, which is in a small element, and iodine due to its larger size in the down the group, then this is a strong acid, due to which, and HF is weak acid. We decide acidity with the help of more H plus ion जो रिलीज करे and the stability of an ion. We can decide acidity with two methods. More we will the H plus ion release or stability of the anion formed. Acidity can be determined with these two methods. So now for the second part of this video, the secondary effects in in which first we discuss about the inductive effect. Well, these are one of the most important effects, as we can see, and we also study this in our bachelor's and 11th and 12th, some parts of it. So it is a very important effect. There are some important points which we'll be writing. So these are some 4 points which is important. It generates due to electronegativity difference, and it is a permanent effect, and it operates via sigma bond, and it is a very distance dependent effect. We actually need to follow here a DNP rule, in which first we check the distance, then we check the number of groups attached, and then we check the power. So DNP rule is followed to identify in different groups inductive effect. So these are basically 2 types, in which plus I and minus I inductive effect. So plus I effect is also responsible for electron donating group, and minus I effect is responsible for electron withdrawing group. All the anions which are rich in nature are performed by plus I effect. In all the cation will show minus I effects. The less electronegative neutral groups structure, like alkyl groups CH3, CH2, C2H5, CH3, CH3, CH2, these groups are come under plus I effect. And if we talk about the minus I effect, it is an electron withdrawing group. All the cations will show minus I effect, which are Garib in nature, and high electronegative groups, example neutral groups, जैसे कि फ्लोरीन माइनस, क्लोरीन माइनस, unsaturated alkyl groups, कार्बन कार्बन, alkenes, alkynes, C triple bond N, etc. will show minus I effect. So as we are writing this is the difference between these plus and minus I effect of inductive effect. Let's take an example of some of the example of plus I effect, in which C minus, M minus, O minus, F minus. We need to know who is showing the plus I effect more. So as we all know, the stability for plus I effect, we need electron donating groups. So if these groups are attached with one another, the order of plus I effect will be this. Why this happened is because the more electronegative group, just like fluorine, the negative charge in more electronegative group is stable, and negative charge in carbon is unstable. So the donation of electron from carbon is easy, and donation of electron from fluorine is difficult. So we know that it is a distance dependent effect. To know about that property, we take an example of carbon, hydrogen, 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 carbon, deuterium, deuterium, and deuterium, and carbon, tritium, tritium, and tritium. So as we know the order, the mass as we go from left to right, the mass is increasing, so the bond length is inversely proportional to the mass. So the donation is more easily from the tritium and from the deuterium and least from the hydrogen, because the size of these elements is remains same, but hydrogen is a little smaller, deuterium is a little bigger, and tritium is even more bigger. So the distance between these bonds is reducing, due to which we know that inductive effect is more distance dependent. So the order of plus I effect is this. So this is also an important relation in which percentage character increases, then bond angle is also increases, the electronegativity is also increases, due to which minus I effect is also increases. These are all in directly proportional relation with each other. Then let's take a few examples of minus I effect, which is the electron withdrawing effect. This minus I effect will show who will withdraw an electron more. Let's take an example of O and the two F's, and O and 2Cl. So as we all know, the fluorine is more electronegative than chlorine, so the possibility of finding the electron is more near chlorine, so he will attract more electron from oxygen also. And these positive charges, which is in oxygen, will more likely to attract the upcoming electron in itself. So the minus I effect order here is in fluorine more as compared to chlorine. There are some general trends for this, just like a cation is more likely to have preferred over minus I effect as compared to neutral atoms or more electronegative elements. Let's take another example. If we take an example of oxygen plus an R group, an alkyl group, and an oxygen plus and a chlorine group. So here, who will show more minus I effect? So the possibility of finding an electron in chlorine is more due to its electronegative nature. So this oxygen will attract more electron withdrawing group. So this oxygen will become more electronegative, more electron withdrawing nature. And we know that this R group will show plus I effect, or it will donate their electronegativity, and it will make this oxygen a little less favorable to attract electron. So minus I order is more preferred here. There are some more examples. Let's take an example of O, R, R, and O, H, H. Here also in this cation, this R group, as we can see, this is an exception, because here repulsion factor is applicable between these molecules, and here no repulsion is seen. So the possibility is this is more. The possibility of minus I effect is in R group more, and this is due to the reason of bond angle. As the bond angle increases to minimize the repulsion between these R groups. As we know, hydrogen is not donating anything here, but R group is donating. But even though it's not, well, to minimize the repulsion, both R group will increase the bond angle in between. So this structure will become like this in case of that. So as we know that the percentage increases, then bond angle increases, then electronegativity increases, then minus I increases. This is the order which is followed. Well, the same concept of repulsion is applicable in N plus R, 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 and in N plus H, H, H. Here also, this group is more minus I favorable. The same reason is applicable here also. And if this central atom will become in larger size, some example of that is after group third, in the fourth group, just like in third group it is applicable. After that, if we take sulfur as an example, then if the 2R group is here, we know that sulfur is a little down from the third period, so the repulsion factor here is not applicable due to the large size of sulfur group, and nitrogen is a small group, so here it is not favorable, and this is favorable over this for inductive effect minus effect. So let's talk about the application of inductive effect. So with the help of inductive effects, we can talk about the stability of carbocation, stability of carbanion, and stability of free radical, and also the acidity and basicity. So let's talk about the first, stability of carbocation. A carbocation is nothing but this is a carbocation, which is a 3 bond carbon and plus charge, the central. It is an electron deficient species with 6 electron present. So as we know, let's take an example of carbon and this 3-methyl group of carbon with 1-methyl group, 2-methyl group, and a hydrogen here, 2 hydrogens here, and 1-methyl group. As we know, who will show the most inductive effect? So we know that this methyl group will donate electron to this carbocation. So here 3 groups are donating and making this stable. So the order of stability is in 3 degree more as compared to 2 degree and 1 degree. So if the stability is increasing, then donation also increases and plus I effect also increases. These are all directly proportional to each other. So let's talk about the stability of carbanion, which is directly proportional to the minus I effect. Carbocation is directly proportional to the plus I effect. So here, in the case of carbanion, as we can see, it is negative charge. So this is donating and making it more difficult. Here 2 groups are donating and here 1 group is donating. So as we know, here if we go left to right, the stability is increasing. So stability of carbocation is inversely proportional to plus I effect. carbon ion is inversely proportional to the plus psi effect. Plus psi effect increases, stability of carbocation also increases. And for the free radical, the third point, and for the free radical, it is just similar like a carbocation, because it is also an electron divergent species. We do not have the, in case of here, we have 8 electrons, just like 1, 2, 3, 4, 5, 6, and for negative 7, 8 electrons. So it is electron rich species. And in case of free radical, carbon free radical, a methyl group, a methyl group, and a methyl group. So this free radical, here 7 electron is present. So it is also an electron deficient species. And well to know about the acidity, let's take an example of chlorine, carbon, double bond oxygen, and an oxygen and hydrogen. And let's take an R here, double bond oxygen, and A. To know about the order of acidity, we know that a chlorine is an electron withdrawing group, so it will show minus I effect, and this R group will show plus I effect, because it is a donating group, electron donating group, and this is electron withdrawing group. To know about the acidity, we first need to abstract this hydrogen and make a carbocation more an electrophile, and see if the stability of this charge anion is, who will reduce this, who will reduce this stability, and who will increase the stability of this additional group. So stability of this carbocation is more in chlorine side. Why is that? Because this is an electron withdrawing group, so the electron density will travel all the way from here to chlorine and make this carbocation an stable one, and this will be unstable, and this donating group will make this electron density even more dense here, and it is an unstable carbocation. So we can know the acidity also. If the stability, if it is more acidic, then it is more stable. So acidity is directly proportional to stability. So as we can see, acidity is directly proportional to minus I effect and inversely proportional to plus I effect. It is also applicable for all the groups in organic chemistry. Let's take another example in consideration, which include a ring. So here a 3-membered ring is attached, and a carbon and double bond, oxygen and hydrogen, and here a 4-membered ring is attached, carbon, oxygen, hydrogen. Well, as we know that the 3-membered ring is the most strained one, to minimize this repulsion, this new beta bond, this group will go a little this direction, and this beta will increases, then bond angle also increases, percentage character increases, electronegativity increases, anion stability increases, and acidity also increases. So the order of acidity is actually in A higher than B. Here is a 4-membered ring, so this is 90 degree, and this beta is a little smaller than this compared to A.